All right, good afternoon. Thank you for joining us. This is Sean here at Zyxel. Today we're talking about our Wi-Fi 7 APs. We've launched four new APs this year, which is a lot of APs to be adding to a space for a newer technology. So I thought it'd be a good idea to just do a webinar where we sort of go over it, and explain what the differences are, help you figure out, what the differences are between the different models. As we go through today, if you have any questions, send them in using the webinar chat or the Q&A, and I will do my best to answer them. So I want to start just really quickly with just a few slides on Wi-Fi 7 for those of you that know that Wi-Fi 7 is new and out there and not really sure what the differences are. The short version of it is faster speeds, more APs in the same area without interference, more users on those APs without interference issues. Some of the ways they're doing that is by using bigger channels. So on the 6 gigahertz radio, you can now have channels up to 320 megahertz. On the 5 gigahertz, not all APs support this. Ours do. And that is that we can now do 240 megahertz channels on the 5 gigahertz radio, where with Wi-Fi 6 and Wi-Fi 6E, that was limited to 160 megahertz channels. They've increased the QAM, which is basically how much data can be compressed and fit onto those radio waves, which gets us like a 10 or 15% improvement in performance. And then we've got some new technologies. One of the cool ones here is called multi-link operation. It allows compatible client devices to simultaneously connect to multiple radios in the access point. So previously with Wi-Fi, even if you had a client that could support multiple bands, they could only connect to one band and one radio at a time. So now with Wi-Fi 7, some client devices can connect to multiple radios, in some cases two radios, in some cases possibly even all three radios, being able to simultaneously transmit and receive data on those radios at the same time. And then we have another cool technology called multi-RU puncturing. So one of the challenges you have as you start using these bigger and larger channels is that basically any interference across that giant channel is interference across the connection. So even if there's just a tiny bit of overlap, it affects all of the traffic being sent. So with multi-RU puncturing with Wi-Fi 7, basically you can use one of these big 320 megahertz channels, and if you detect interference on, say, a certain 20 megahertz portion of that, you can choose to just simply not broadcast on that 20 megahertz where the interference is coming up from. So now you're technically using a 300 megahertz channel. So there is some bandwidth reduction, but there is no interference. There aren't any additional drop packets or other issues that go along with interference. So it allows you to use these bigger channels with less drawbacks. So, and a big part of that is the use of the 6 gigahertz spectrum. This was something that was added with 6E and is fully part of Wi-Fi 7. So with the 6 gigahertz here, basically we've unlocked a huge chunk of spectrum that can be used by unlicensed indoor users, that basically gives you more bandwidth available than both 2.4 and 5 gigahertz combined. So one of the big benefits of this is you can now have these a lot of APs in the same area, and you don't have to worry about them overlapping. So to give you a reference here, using 160 megahertz channels on 5 gigahertz, there are only two channels, non-overlapping channels, that are available to use. So as soon as you have three APs, you have interference issues if they're all trying to use 160 megahertz channels. In the case of 6 gigahertz, we've got seven non-overlapping 160 megahertz channels. So you can deploy seven APs, all using 160 megahertz channels, and have no overlap or interference until you get up to eight. And generally, by the time you've got eight APs, they're going to be spaced out far enough apart that you aren't going to have interference issues. So I do want to talk now by starting by talking about our Wi-Fi 7 APs, by talking about what's the same between them. So all of our business class access points, everything from the NWA 100 series and higher, uses our RF first by design philosophy. So what this does is these are tweaks and changes we've made on our motherboard specifically designed to optimize the RF performance. So one of the things we do that most of our competitors don't do, um, is that we have additional shielding for overlapping LTE and 5G cellular signals. So in a lot of big buildings, cellular signals don't penetrate the buildings very well. So what happens is they use what's called a DAS system, which basically deploys a bunch of what are essentially cellular access points throughout the building to rebroadcast the signal. And in many cases, those channels are bordering the Wi-Fi channels. And when our Wi-Fi AP is close enough to the cellular AP, you can run into interference issues. So our filtering helps protect you from that. You'll also notice most of our new Wi-Fi 7 APs are rectangular. And the reason for that is, again, it provides less EMI issues between the different radios. Since you've got up to three radios operating at the same time, it helps create greater isolation between those radios so they don't have interference with each other. And you will see other little tweaks like most of our APs. The antennas are not mounted onto the main PCBA like most of our competitors do. Instead, we've got the antennas mounted on their own board and usually some form of RF shield between the antennas and the main board to help with EMI issues and boost your signal to noise ratio. The other thing that all of our APs are using is some version of our multi-mounting brackets. This comes with the APs, and it's a very versatile bracket. It's designed so you can mount it directly to a wall or ceiling using screws. It's also been designed so the screws line up with standard outlet boxes and junction boxes, both rectangular and round, so you can use the existing screw holes in those junction boxes and mount it directly to the junction box that the cable's coming out of. And then these also do include support for our optional T-bar brackets. These are little brackets that you buy that clip onto the T-bar itself that most drop ceilings use. And then you screw the mounting bracket directly onto those. And then all of our APs we talk about today can be managed with Nebula. So Nebula is our free cloud management platform that gives you a single pane of glass to manage all of your customers, all of their networks, all of your devices. The free version of Nebula has no limit to the number of devices or customers that you can manage. And it's a really convenient way of managing your devices. All of these APs, though, also do support traditional management directly through SSH or a web GUI. So if you don't want to use the cloud, you do not have to. Now, one of the key things you will notice about our access points, especially if you've been selling them for a while, is that we've got two different series, the NWA series and the WBE series or the W series. So on the Wi-Fi 6 APs, it was the WAX series, etc. And generally what you're going to see is you're going to see very similar hardware available in the NWA series and the WBE series. And that is something we've done forever and will continue to do. And you will see that with our Wi-Fi 7 AP. So it brings up the question, why do I buy the W series instead of the NWA series? So I just wanted to briefly talk about this because this is going to be important as we go through the AP slides. So if you buy a W series access point, it comes bundled with 1 year of Nebula Pro Pack. So that is an optional license which unlocks a lot of additional features in the Nebula. Things like a year's worth of audit logs, automatic topology views, artificial intelligence that can automatically tweak Wi-Fi settings based on client connectivity that we can see, things like that. So if you're going to use Nebula Pro Pack, it might be a good idea to just go ahead and buy the W series so you get that license automatically bundled in there for you. The W series also supports our local wireless LAN controller. So if you're not using the cloud and you're deploying a lot of APs, you're going to want to manage them with some form of local controller. And that is something the W series supports. The NWA series does not. The other thing you will find on most of our APs in the W series is they generally have advanced antennas built into them. So our traditional access points have an omnidirectional antenna that's been optimized with the idea that you're going to mount it on the ceiling above the area to be covered. And so that's what you'll find in the NWA series. Where with the W series, we have our dual optimized antennas and our smart antenna options. And we will talk briefly about those a little bit later when we get to those devices. The W series can also be used with our secure Wi-Fi functionality. So this is an optional license that's part of our security appliances that allows us to convert a access point into a cloud-managed remote VPN appliance. It's a very easy way to deploy in-home or at remote offices VPN connectivity without needing to worry about things like double NAT or installing software on the user's devices, etc. Other features that you'll find in the W series that aren't in the NWA series is collaborative detection and response. So this is a way for the access points to coordinate with our USG Flex series security appliances to provide additional protection on the local network, and also the ability to support GRE over IPsec tunneling for those of you that want that level of security where your wireless users have all of their data GRE tunneled back to your security gateway before allowing them onto the LAN. So we'll start by talking about our Band Flex APs. So Band Flex is something we introduced with the Wi-Fi 6E products. And for Wi-Fi 6E, we were the only vendor that was doing this. Now with Wi-Fi 7, we are seeing other vendors starting to support something similar to our Band Flex. So I do want to talk about that here briefly. So basically, the short version of Band Flex is that with Wi-Fi 7, we now have three radios that we can support, a 2.4, a 5 gigahertz, and a 6 gigahertz radio. So in theory, you can have all three radios operating simultaneously. The challenge you run into in this is cost. So obviously, you've got three radios. Three radios cost more than two radios. You also need a more powerful SoC to handle all of the users and bandwidth that those three radios require. The other challenge you run into with three radios is they eat a lot of power. So one of the challenges with a lot of Wi-Fi 7 access points is they cannot be used with your standard 30-watt PoE power switches. Instead, they need to go up to PoE++, also called 802.3 BT, which is your 60-watt PoE. So if you're upgrading to Wi-Fi 7, do you really need to also then upgrade all your switches at the same time to support higher PoE to power those access points? Do you need to upgrade your switches and infrastructure to handle the faster speeds, right? Some of these tri-band access points are pumping out more than 20 gigs of data coming out of them. Can your wired switches support that? So because of that, there's a big demand for Wi-Fi 7 APs that can be easily deployed, upgrade the network, but don't require you to replace all your switches and stuff like that at the same time. So that's where Band Flex comes in. So what Band Flex is basically access points that only have two radios. So they'll have a 2.4 radio, and then in the case of our Band Flex APs, a second radio that supports either 5 gigahertz or 6 gigahertz. It's software selectable which of the bands you want to use. Now, this is something that sets us apart from our competition that's out there that we're competing with. So our competition from Ubiquiti and TP-Link in the dual radio Wi-Fi 7 space only supports 5 gigahertz, whereas we support 5 or 6, and you can switch between those at any point. So the benefits here for you is basically right now there aren't a lot of 6 gigahertz clients out there, so you probably don't need 6 gigahertz support today. But we give you that flexibility that you can support your existing 5 gigahertz users today, and when 6 gigahertz becomes much more ubiquitous in client devices, you can then simply flip a switch and support those 6 gigahertz users. It reduces the cost of the access points, keeping them more affordable. And it also means it's going to work with your existing 802.3 AT 30-watt PoE switches and infrastructure. So you aren't having to swap out your switches and possibly even your cat cables that are in the walls in order to be able to support Wi-Fi 7 access points. So it's an affordable, easy way to upgrade your 2.4 and your 5 gigahertz radio to Wi-Fi 7 today. And then if you do need 6 gigahertz support in the future, when it becomes more common, you can switch over support to that. So now we'll start talking about the different access points, and I have gone ahead and grouped the slides based on the hardware specs. So what you see here is when it comes to BE 6500 or 6.5 gigabit access points, we have two models, the NWA 110 series and the WBE 510D. So basically from a hardware perspective, they're the same. They have the same wireless performance. They have the same port configuration. The differences are all those things we talked about earlier when I was talking about the differences between the NWA and the W series. The 510D supports the local controller. It supports secure Wi-Fi. It supports collaborative detection and response. It comes bundled with that 1-year Pro Pack license. The other difference when it comes to hardware, or the only difference when it comes to the hardware itself, the physical hardware, um, is that this supports our dual optimized antennas. So the W series comes with dual optimized antenna. The NWA series just has your standard antenna. From a port perspective, both of them here have a 2.5 gig uplink port that requires 30-watt PoE to power it up. Alternately, if you don't want to use PoE, all of our new Wi-Fi 7 access points, we've replaced the old barrel plug AC power adapters with standardized USB-C PD. So you can use any USB-C PD power delivery wall wart or plug to power your access point using a standard USB-C power cable. So let's talk briefly about dual optimized antennas. So again, your traditional AP has a ceiling, is designed for ceiling mounting. They assume you're going to mount it on the ceiling, and the signal radiates out in roughly a umbrella pattern outwards and downwards from that access point. But out in the real world, you don't always get to mount your access points on the ceiling. Sometimes you have to mount them on the wall. So with dual optimized antennas, we give you two sets of antennas, your ceiling mount optimized antennas and a set of antennas that are optimized for wall placement. So instead of sending your signal up into the floor or down into the floor, up into the ceiling, it's optimized to shoot the signal outwards from the wall and provide great coverage that way. So that's just a software switch you can flick or a physical switch that you can flick to switch the AP from ceiling mode to wall mode. The next APs we're going to talk about here is our BE 12300, or 12.3 gigabits per second wireless communication. So in theory, over 10 gigs of throughput. And again, we've got the same situation. We've got an NWA 210BE and a WBE 630S. The differences are the differences between the W series and the NWA series. And then on the hardware, the difference is that the 630S has smart antenna built in. On the port configuration here, what you will see now is there are two Ethernet ports, whereas the 110 and the 510 only had one Ethernet port. So this has got a 2.5 gig uplink port and then a 2.5 gig pass-through port. So this allows you to daisy chain. So you can run one cable to the access point and then run another cable from the access point to an Ethernet port in the room or to another device in the area. So you're not having to run two cables when you can get by with just running one. So smart antenna is our premium antenna solution. It's a generic term, and I wish we'd really came up with a brand name for it. Performance-wise, it's similar to, we'll say, Ruckus's BeamFlex Plus. So if you're familiar with Ruckus and their BeamFlex Plus, that is their branded smart antenna solution. And we offer similar smart antenna here. So the idea behind smart antennas, it increases capacity. You can get more users on one access point, and you can crowd more access points into the same area before you start seeing interference between those access points, and it increases coverage. So how does it work? So whereas a traditional access point has that one antenna pattern, whoops, sorry about that, or our dual optimized antennas have two selections. Smart antennas use an antenna array. So you actually have the ability to have hundreds of different antenna patterns. And our algorithm takes a look at where the client device is in relationship to the access point and chooses an algorithm that focuses the signal towards that client device. Now, unlike beamforming, the client does not need to be stationary. This works with mobile client devices. Doesn't require anything special on the client, works with any type of client, any Wi-Fi technology, BGN, the old stuff still works with it. The other thing our algorithm does, and does a very good job, of it finds out where other sources of interference are in relation to the access point. Now, in this graphic, it shows it as a microwave, but more likely, or the most common thing you're going to run into, especially on 5 or 6 gigahertz, is other access points on overlapping channels. Whether it's just because you've deployed a lot of access points, or it's because your neighbors or neighboring offices have their own access points and you have no control over what channels they're using. So our smart antenna can basically ignore sources of RF interference. And because of that, when you deploy our access points, we're able to achieve greater than 100% airtime utilization spread across two APs, two or more APs that are operating on the same channel. They're essentially able to each broadcast at the same time without interfering with each other, so allowing us to achieve greater than 100% airtime utilization in the area, something you cannot do without smart antenna technology. So now we are done with our beam flex access points. So those are our dual radio tri-band access points. Now I want to start talking about our tri-band tri-radio access points. So these are access points that have 3 radios operating simultaneously. So they will be operating on 2.4, 5, and 6 gigahertz at the same time. So the first one we're going to talk about here is our NWA 130BE, which is similar hardware to the WBE 530. So previously, when we've been looking at the NWA versus W series, the W series models have some extra antenna technology, right? The dual optimized antennas or the smart antenna. So in the case of the NWA 130/WBE 530, there is no antenna difference. Both of these have your traditional standard antenna. So we often get the question, why? And the answer to that is because we're running 3 radios here, and we're getting pretty close to that 30-watt limit that standard PoE supports, right? That standard 802.3 AT, PoE plus, whatever you want to call it, supports. And if you add in the smart antenna or the dual optimized, we're getting too close. We technically could do it, but it's getting us really close to that 30-watt limit. And the challenge you run into with deployments is the longer the cable run, and also just depending on the quality of the cables themselves, that 30-watt power drops over distance. And we don't want to run into a situation where certain ports are working with PoE and certain other ports aren't able, the APs aren't able to boot up because the cable run is too long or the cable quality is too low. And because of that, the signal has dropped below what the access point needs. So to make sure we have enough buffer, it was decided to leave off the extra antenna technology. But all the other differences between the W series and NWA series are there. And this one here, much like we were talking about earlier with the 510D and the 210, is this does have 2 Ethernet ports, both 2.5 gig multi-gig. So you have one uplink and one pass-through port here. And then lastly, for those of you looking for ultimate performance, we have our WBE 660S. And I thought I had removed the animation. My bad. In fact, I was sure I have removed it. It's not going to display. There we go. We finally got it to display. Okay. So I need to figure out why that is because the animation tab was empty. Anyway, so this is our most powerful Wi-Fi 7 access point. So because of that, it does need 802.3 BT PoE power or 60-watt PoE power to power this up. Or you're going to need to buy a higher powered PoE injector to put in line, or you're going to need to use that USB-C power delivery with a 60-watt PoE PD wall wart or source. But this has got our smart antenna technology. This is the maximum on speed. So this is providing BE 22,000 class speeds or 22 gigabit class speeds. Now, again, when we're talking about Wi-Fi, we're talking about Wi-Fi client to Wi-Fi client speeds, and it includes all the protocol overhead and stuff like that. So, realistically, it's not, you're not going to see that on a speed test, but it is what's going on the Wi-Fi side of things. So this big guy here, in addition to those speeds, has Bluetooth built in or Bluetooth low energy. For those of you that use that for marketing purposes or for like smart museum self-tours and things like that, it is built in on this model here. Because of how much power this guy is sucking up, Unlike our other APs where the back of the AP is just plastic with vent holes and there's a heat sink inside underneath the board, in the case of the WBE 660S, the entire back of the board is a heat sink. It's a large metal back of the board to be able to make sure we get enough heat out of the case and vent it outside the access point itself. It has a 10 gig uplink port to help support those faster wireless speeds. It does have a pass-through port, but unlike on some of the other models, it's only a 1 gig pass-through port. It is not a 2.5 gig pass-through port. So with that, guys, we have talked about all of our access points. Again, if you have any questions, send them in using chat. We've still got just a couple more slides to go, but that's it as far as talking specifically about the hardware itself. So, why should you buy Zyxel's Wi-Fi 7 products? In addition to the things we've talked about today, like RF First, or the fact we're selling, $120 Wi-Fi 7 APs with lifetime warranties, where our competitors in that space generally are only 1 or 2 years. We have been doing Wi-Fi for a long time. I know a lot of you know us because of our switches or know us because of our security appliances, but we have been doing Wi-Fi since before 802.11b. We were one of the very first vendors to do it. We also used to develop our own chips. We developed some of the first technology that's led to today's ability to do MU-MIMO. And our chipset division was spun off and sold to Qualcomm, so they are part of Qualcomm these days. And because of that, we still have a very good relationship with Qualcomm. We are one of their primary or alpha partners. So we get first access to their software, we get first access to their chips, and we have a very good relationship with them when it comes to being able to implement things. We have also been some of the first. We were the first in North America to ship a Wi-Fi 7 true business class access point, beating many of our competitors to actually shipping the product. We were also one of the first vendors to automatically turn on multi-link operation across our entire Wi-Fi 7 access point lineup. So lastly here is a slide comparing all of those different models. So start taking notes, writing. I'm going to leave it up for 5 seconds and we're moving on. Now, we have a better version of this. We have a new Wi-Fi 7 battle card, which should be completed by the end of this week. We could send you a draft version of it today. So if you want something like this, which shows you all the different Wi-Fi 7 models and the hardware differences between them, reach out to your sales guy, Jacob, David, or Andy, and they can email you that battle card, which has a lot of the same information. In fact, has a lot more information. It also touches on some of the software differences between the models. So reach out to them and they can hook you up with that. And that concludes today's presentation. Just as a reminder, all of our webinars generally get recorded and uploaded to our YouTube, so you can always view these on there. Our YouTube channel also has things like video case studies, best practices videos, product announcement videos, etc. And if you have any questions, you can always reach out directly to me. My email's up there on the screen. It is Shawn R., Shawn spelled S-H-A-W-N. So Shawn R at Zyxel.com. Or you can always just reach out to your salesperson. They can forward any questions to me or loop in our sales engineer if they need it. I'm not seeing any questions coming in, so I'm going to go ahead and end today's webinar. Thank you for coming out today and listening to me. I hope you learned something from it. And I'm always open to feedback for new topics or suggestions of things you'd like to see us cover in future webinars. Thank you for joining us, and I hope I see you at one of our future webinars.